Is our review day, but let's start with answering this quiz. Okay. Charge balance. Naya, how would you write the charge balance equation here? All the cations on one side. Am I missing any? Oh, there is another one.
Yeah, and the H plus. Don't forget H plus.
All right, Naya, you didn't. It's not as simple as all the cations on one side, all the anions on the other. Because you gotta bring all the charges out front. No candy for you. Right? Okay. Well, I don't think I'd knock off points if you wrote H plus, but I don't think you should have it in there. In fact, I guess I will knock off points if you have H plus. Because it says by dissolving to give a solution containing, this is very specific. This is all that's present. The solution contains these. If you want to identify H plus and OH minus, you're just introducing more unknowns, but you have to introduce more equations too, like the KW expression. So you're really not helping yourself. So this specifies these are the ions that are there. So it's already done that first step for you, identifying the ions. So you put all the cations on one side, all the anions on the other, charges out front. I think we have them all. Okay? And then it wants mass balance. No, you didn't say 2. This is not easy stuff here, Danielle. How would you write a mass balance equation? Danielle, how would you write the mass balance equation? Say that you have MgBr2. Yeah, but MgBr2 is not in solution. But you do have, this is where it's starting out though with MgBr2. So which one would you have more of? Would you have more of magnesium in all its forms, or would you have more of bromine in all its forms? You sure? Because you break this up, you have a magnesium, and how many bromines? 2. So yeah, the stuff might funky happen in solution. But the point is that you're going to have twice as much bromine containing concentration as you would magnesium. Do you see that? So it might be easier when you have a number down here. You almost always have a number. But I wanted to do it up here just without a number too. So essentially, you'd put all the magnesium forms. This one, actually, it's going to be really complicated because you're going to have magnesium forms on both sides. It's really getting kind of ugly. So this question is really right. If I'm going to grade this, I think I'm just going to grade the top one, because the mass balance one, you're going to have the same term on both sides, and it's just getting ugly. It's not making a whole lot of sense. It's not going to be very helpful. So I think all I'm going to do is just change this to, because I just wrote that. Let's just change that to write the charge balance for this top one. But the bottom one will make more sense to write a mass balance, because now we've got this. So let's write the mass balance down here below, which would be more fitting for our homework and our problems that we're solving for anyway. So we could say what? How would you say this in English? In all its forms is 0.5. So it's easier. I think it's easier. So the concentration of magnesium in all its forms is 0.5. That will be one mass balance. And then you can put in the terms, concentration of Mg in all forms is 0.5 molar. There's one more. What would it be? Ricky, what would be the other one?
Concentration of bromine in all its forms is 1.0 molar.
There you go. Concentration of Br in all forms is 1.0. How do you get the 1? How do you get the 1?
The subscript.
How do you get the 1? Oh, yeah, sorry. You can give it to Gloriana. Ah! Why? Because of the 2. Exactly. When this breaks up, you get twice as much bromine. Ratio of 2 to 1. So that's why you've got a 1 here. So with magnesium in all its forms, right, all the species that contain magnesium would go over here on this side. So you'd have this one, that one, right? And then for the one that has 1.0 molar, everything that has bromine in it. Well, looks like there's only 2 of them because this one didn't exist in solution. It's not a complex ion. See that? No. That's how I straighten it out myself. All you need to write is Br minus and MgBr plus. So this would be, you should be writing that one, right? This IDA saves me. That's why I write it. That's why I say it. And then magnesium in all of its forms has to be a half molar. So you have Mg plus 2.
So all the tests, if we put concentration of Mg in all forms equals 0.5 molar, would we get it wrong?
Hey, let's get the answer here. Just a sec. Magnesium, the other one is MgBr plus and MgOH plus. Okay. I guess 1, 2, 3, 1, 2, 3. Okay, so the question is, if you wrote just this part equals 0.5 molar, would you get it wrong? Yes, because that's not an equation, right? This is just a sentence so that you can write the equation. And then someone was talking about having hydroxide in there, or H+. Now realize with Dr. Smith's 5-step plan, right? If you're doing a full systematic treatment, and if you have H+ or OH- showing up, then you'd have the other one. So really, even if you're doing a full systematic treatment here, you wouldn't be adding H+ and OH- according to the 5-step plan, because your species are all identified. And you can't write you don't see any Kas or Kbs here to write. You don't see Kw to write. You don't. I mean, you can, but you don't have to. So you shouldn't.
On the test, then, we should do what you did here?
You should, on the test, you should do what we do in class and homework. And
because in the book, I was going to ask you, in the book, they have one they have a few just like that,
yeah.
where they say, this is the species you have in solution, and then when you write the charge balance in the answers, it says it includes the H+ and OH. So I was wondering on the test, should we do that?
Again, if you introduce H+ and OH-, then remember the 5 steps. Let's look at the review here. Remember the steps right here. Step 1. If you identify H+ or OH- in there, yeah, if you have one, then you got to have the other one. So if it's not identified, you don't need to. You're right. Go back in the very beginning, if we had like strontium nitrate or whatever. Let's go. That was let me show you the exact question I'm talking about. This is day 23 or something, right? We had some problems. Yeah, that's where it started. Let me show you. I want to show you exactly what I'm talking about. Here, okay, right here. It's aqueous. Dang it, H plus and OH minus are there. You can't stop autoprotolysis. But why introduce them? You don't need to. You introduce these, then you just have to add more equations then. You don't need to. So you identify the species present pretty much only if you need to. Right? So that's why it was set up in the way we did it here, is we pretty much just wrote one at a time. And then if we ended up writing a KW or a KA, then we went up and we added some more. So right at the beginning, I wouldn't start listing out all these things, even though if you're in water writing H plus and OH minus. No, because you don't need them. If you do introduce them, I'm not saying it's wrong, because they are there. But then you have to write 2 more expressions. So you're going to make it more trouble for yourself. So this is about it's complicated, but this is about as simple as it can get with the 5 steps.
We won't get it wrong if we do go to the...
You'll get it wrong if you introduce H plus and OH minus in this problem right here, just to be specific. If you identify H plus and OH minus in there, then I don't care. However many chemical species you have,
That makes sense.
you better give me an equation for every single one. Then if you did, great, you're done. You just have to go through more work.
Like number C right there, you have to introduce HF, right? Because it's not a weak acid. It's not a strong acid.
Yeah. Now in C, the way that we do this, so we avoid introducing things we don't need to, is what we did in class was NAF a possibility? No, don't write NAF. And we talked about why. So you'd have Na plus, and you have F minus. And then you just probably went on to the next step, unless you've worked a bunch of these. And then you say, oh, can I write any KW? No. Can I write any KA? No. Oh, but I can write a KB. I guess doing this, you need to remember, oh, either I write KA or KB. Right? No, you don't write both. So I can write a KB. So then you write your KB expression, and then the OH minus pops up. So you have the OH minus up here. Then you realize, oh, now I can write a KW expression. Oh, now H plus shows up. Right? So in that sense, at least by doing it that way, we're not writing anything extra. We're guaranteeing we're only having the minimum by doing it that way. If you do it stepwise. But if you've done it a lot, and you could say, oh, I know I'm going to write a KB. Right? Well, I know I'm going to write a KW. Well, if I'm going to write a KB, I'm going to have HF in there, right? So if you've done this a lot, you can do this, but it's kind of risky because you may be writing something you don't need. But I don't know if that answers your question.
Yeah, it does. It's just in the book there was a lot of homeworks and they kind of ingrained that in. You know, like they tell you there's this species in there, and then they go back and it's kind of like, it seems like a trick question because then they end up putting OH minus and H plus in the charge balance, and it's confusing. You know?
Yeah, I would just. I don't know.
It seems like a lot.
I would do it.
They're telling you there's these species, and they're like,
their game plan might be different than mine.
Mhm.
So I would just. I know this. So I didn't write up the book's plan because I guess I liked mine better. Okay.
I have a question.
Mm-hmm.
Do you add the magnesium to both?
Yeah, it's here. Whoop. It's here, and it's here. So I mean, we could have wrote the balances up here. I mean, we'd have to have 2. All right, this is the mass balance one. This is charge. And if we did mass, we'd have, and it's MgBr2. So bromine is going to be twice that of bromine. Is bromine twice as concentrated as magnesium, or is magnesium twice as concentrated as bromine species? How do you say this? It's MgBr2. So which one's more concentrated? bromine is twice as concentrated as magnesium. Does everybody agree with that statement? Right? Bromine is species is twice as concentrated as magnesium. There's no other way for me to do this but do the English. So wherever you say is, that's where you put the equal sign. So we said that bromine, so this must be the bromine, guys. Bromine is twice as concentrated as magnesium. So this would be all my bromine species, if we wanted to write this one. This would be all the bromine species. And you bet, some are going to be written in there twice. Right? Some are going to be over here, and some are going to be over here. But then we have to do some algebra and simplify it. But here's all the magnesium species. And you better write them on both sides. Right? Right? Some bromine species contain magnesium. Some magnesium species contain bromine. Yeah, they better show up on both sides. Okay. So I guess we could write, that's not that bad. It's getting ugly. Okay. So these are more like just getting the concept down of writing a charge or a mass balance equation. So if we want to apply the whole thing and get an answer, it won't quite be that complicated because, my goodness, so many equations, so many unknowns, it gets to be a lot of work. So for our review for exam 3, that's where this stuff is coming from. We've got some problems where we are we're starting out by disregarding this full systematic treatment. All we're doing is just doing activity problems, right? Same thing here, we're disregarding the full systematic treatment, just using activities. So when it's just a using activities problem, you just set things up as normal, right? That just like we did, if you're calculating a pH, or if it's a Ka or a KSP or whatever, you set it up as normal. Just replace all concentrations with activities. And then you're probably going to have to interpolate to get the fudge factors, the activity coefficients. So that's what we'll be doing in these two. And it's set up so you will have to definitely interpolate. And then then we have a couple where, okay, let's forget activities now. Let's just do full systematic treatment, okay, and get the answers for these next two. Okay. So now you're using full systematic treatment. Okay, so it's really one type or the other type. So where would you like to start? I was question 1, I guess would make the most sense, huh? Let's just start at the top and work our way down. So here's the equations that are given on the exam. The one that isn't, that interpolation ratio. Okay. Using activities and disregarding full systematic treatment, what is the pH of 255 mils containing 0.0293 molar HNO3 and 0.065 molar NaCl? They want to know what the pH is. What's the equation for pH? Yeah, except we don't want to use activities, all right? So what we need to figure out is what would I replace, what would I put in there for the activity? Sabina, what will I put in there for activity? Just to make another expression here, what would I put in there? Whoa, I'm losing everything here, just wait. What did you say? For the activity, also it'll be negative log of okay, there's my hydrogen ion concentration. But I have to multiply that times. And what was the symbol for the activity coefficient? That little gamma thing. Yeah. Okay. Now, do you hear what Sabina said? She's told us what this one is. So what does this 255 mils have to do with anything? Nothing, right? You can take a big jar and measure the pH of half of it, a third of it, 10 mils of it. You get the same pH. It's the same solution. Volume doesn't matter. Okay. How about this 0.065 molar NaCl? Gloriana, what does that have to do with anything? What is this doing in there? Yeah, does it matter? We never cared before. All we did is take the negative log of the hydrogen ion concentration. But Sabina's complicated our lives here because she said it's not just hydrogen ion concentration. It's hydrogen ion concentration times that gamma thing she said.
No.
Anybody help her out? What's this 0.065 molar NaCl doing in there?
Wouldn't you add that and the concentration of the HNO3 to look it up in the table?
Yes. Okay, now what's the word she's she's giving away all the candy here. What is the word you're missing? Here, we'll give it to Andy then.
Congratulations.
What word is she missing? She says look it up in the table. But look up what? What is it called? Ionic strength. Mu. Right? And she said, Monica said just add them up. Why is it that simple? Why don't we have to use this big equation? Why don't we have to use that big equation? She said just add them up. Add this to that, and you've got the ionic strength. Why does that work?
1-to-1 ratio.
1-to-1 ratio. Right? Pass that down to the big guy. 1-to-1 ratio. All right? If it's not 1-to-1 ratio, if it's not 1-to-1 ratio, you better use that equation. Right? It's not 1-to-1 ratio. You better use that equation. Okay. So find the ionic strength. I bet you 0.065 and 0.0293, you add them up, I bet you it's not going to be in the table.
Yes, it is. Never.
I was going to say, holy cow, really? What is 0.065? What is it?
0.943 or 0.0945.
Okay. Yeah, so we definitely have to interpolate. All right? So interpolate, get the actual activity coefficient, or gamma. And I like to guess first. I think it's healthy to guess because it's really easy to screw up on this. Write the point immediately below and above an ionic strength, right? I would guess. Just write off a little guess on the side. We need a table. I guess we could use our book here. All right. What page is that on, Desiree? I don't have page numbers. I don't have page numbers? Page 83? Okay. So we've got 0.01 is immediately above it. And 0.05 is below it. 0.01 is 0.914. And 0.933. So if I was going to guess, I'd say, I don't know, 0.92. That's just my guess. So it only takes a second to do, but that way if I interpolate and I get something around my guess, I know I did it right. So hopefully you pick these 2 points above and below it. Oh, a 0.01, that's not right.
What?
I need 0.1. I'm a little off. 0.1 is 0.83.
Yeah, and the 0.005 should be 0.05.
Yeah, and I want 0.2. 0.05, yeah. Ouch, I'm off by 10. That should be 0.86. So maybe 0.84, 0.85, something like that. Somewhere between them. 0.1, 0.83, 0.05, 0.86.
Did you solve it already, Ricky?
Yes.
What'd you get?
1.612.
I did that.
I had it lined up the way he has it lined up there. It gives you the right coefficient. 0.8334.
Oh, okay. Never mind.
That's the
I'm not done
coefficient.
yet.
Yeah. Almost.
Did you get a pH yet?
Yes. Yeah, so the endpoint outlet's up there in green. It's 1.612.
Yeah, but I've made mistakes before, though.
That coefficient, that's what I got too.
That's what I got.
Oh, I did work? Okay, good. Thank goodness. I haven't been doing so good about giving answers. What did you get as your little activity coefficient?
I got 0.83.
0.83.
83342 if you carry it out.
All right.
Okay, Brad.
Brad? Did he do that?
Yeah, like an analytical Eurydice field. Well, technically, shut up.
So somewhere around 0.833 something, get your activity coefficient. And make sure you put that in up in your pH expression. Multiply it by your hydrogen ion concentration, and you should get 1.612. If you get it, try the next one. I give you the answer in green. Try to find the solubility using activities. If you're having trouble, just ask. Get it to work? Danielle, did you get it to work?
No, I'm still figuring out
How to solve for gamma?
So are we using this one?
Oh, you're doing this, but you get the top one done.
Oh, I thought we went to the next one.
Well, all this, see, 0.093. They want the pH, so that's what this is. Find the pH.
Yeah, I'm just copying this.
Okay. So then you're interpolating. Yeah, so here you have your gamma here, your question mark, right? So you have to solve for this. So I would take this, divide it by that, times this, add 0.86. Well, it's minus this. Write your gamma or something in there. Because it's gamma minus that. Right.
I'm not getting this. Because
Why do you have a plus here?
Because on the quizzes, whenever I subtracted it and I tried to put that, it was you marked it as wrong.
Well, you're doing something wrong. Because if you
This is how.
did you set it up like? Does that make sense? How I set this up? All right. Let's first agree with this.
Yeah.
Because what I did, I took the 0.05 minus 0.0943. Right. Oh, I do too, don't I? Because look, I did 0.0943 minus 0.05. Just have to be consistent. So I took 0.0943 minus 0.05. So on the other side, I have to take gamma minus 0.86 to be consistent. Then on the bottom, I have 0.1 minus 0.05. So on the other side, I have to have 0.83 minus 0.86.
Oh, okay, I see what
You got to be consistent. It doesn't matter how you do it, just be consistent.
Okay,
So if you do question mark, where are your 2 points?
right here.
Question mark minus 0.86, then this one has to be 0.0943 minus 0.05,
Mm-hmm.
okay? And then down here you did 0.86 minus 0.83, so this one has to be 0.05.
Oh, okay, so then
Minus
this one
0.1.
either has to switch, either one has to
Yeah, just be consistent.
Okay, that's probably
But if you get a negative sign, just erase it. You messed up somewhere, but
right.
you should get 0.833. You're probably doing something wrong here is what you're probably doing wrong. There, you got it, 0.886.
No, I still have to do all this.
Oh, the answer's 0.833. Keep going, yeah. You're right.
Okay, yeah, there we go. Thank you.
Okay, anybody set up question 2? Naya, did you write a reaction? Marlena, did you write a reaction for question 2? Well, let's try it. What'd you write? BA 2 plus and yeah, that's right. Okay, there's your KSP reaction. Okay, and then solubility is the what and what? X and ice. Okay, so let's get into a table with X's in it then.
Why wouldn't you add the wouldn't the polarity be together?
No, because polarity is just for H.
Now, before I put dashes in this initial row, I should read the question. I get a little too fast. Is this a common ion effect problem? Do I have any initial barium or fluoride in there? Yeah, I mean, I could have just changed this to KF. It could have been a common ion effect problem. This would have just said KF is all, but it didn't, so there's nothing there. X, 2X. Right? So my KSP is 1.84 times 10 to the negative 7. That has to be the activity of barium, the activity of fluoride, but squared. Okay. And it's nice to write this intermediate step, because if you do this, odds are you won't forget to square those little fudge factors, those gammas. So So it's kind of nice to write this, I think, because they said to use activities. So usually we write the concentrations of products over reactants, but they want activities. It's great. So so don't use concentrations, use activities. So the activities of the products over reactants. So that would be barium and fluoride squared. And then put in the rest of it. Activity of barium. Concentration of barium. Whoa, what happened there? The activity of fluoride. Concentration of fluoride. Okay, but this doesn't have any X's in it. So how do we get our X's in there? Andy, how are we going to get our X's in there? Well, yeah, we will, but I just want to get my X's in there so I'll feel more comfortable. Replace what with what? Yeah. X instead of BA and
2x instead of
yes, that's what I was shooting for. I want so that way I wouldn't skip any steps. So from the ice table, you said put in the X for the barium. Whoop, I forgot my fluoride. Coefficient. And my 2x for my fluoride. Okay. And like you said, solubility is the X in ice. So at least now I have my equation with X's in it. I just have to get these activity coefficients. Hopefully I do. Oh, shoot, right? You are going to have to interpolate. Could have been a lot easier if that would have said, I don't know, 0.01, 0.1, something in the table, but it doesn't. So you're going to have to interpolate to get what these activity coefficients are. And make sure you square the fluoride once you get it. And then we'll just solve for our X.
Oh, I see. I thought you wanted to answer in grams a liter, but that's what I got for the molarity, though. I converted it to grams a liter.
Oh, yeah, I didn't specify. So since you got that far, let's what did you get? 1.84 times 10 negative 7. Ricky, what did you get for your activity coefficient for barium?
For barium, it was 0.8. Oh, no, never mind. Sorry. That was for fluorine. Barium is 0.572625.
Oh, that's enough. Okay, times X. And then the fluoride, you got?
0.857.
Something like that. You got to square it. And 2x. Okay. So using activities just introduces some little fudge factors and then that change your answer a little bit to make it more fit the real world. Take into account these interacting ions.
So for the, to find the, so we would use the 0.029 for the.
Yes. The 0.29 is going to be, what's the word? Starts with an I? Ionic strength. That's going to be our mu. So we need to set up a little table for barium. All right, and you're right, 0.029. And solve for the activity coefficient. Do the same thing for fluoride. Okay. And use our table. So you can find them in the table and fill those in. There's barium. 0.029. Barium's right there. So you got 0.05. 0.01. Whoa. .05 barium is 0.465. 0.01 barium is 0.67. Yeah. And the number he got is in between, so that looks right. If you interpolate. You put fluoride, 0.05 and 0.01. The numbers Ricky got seem to fall in between, so I think they look right. Oh, about out of time. We're about out of time, but see if you can wrap that one up and get 4.8 times 10 to the negative 3 for your x. Right. And then there's some systematic treatment problems to practice with. Give them a shot. Come on by. I'll be here all. We have lab all tomorrow morning. You can work some more problems there. I can make some up.